Welcome back, everybody. Giving you some time to recover from the break. All right. Okay. So let's. Oh yes. Thank you very much. Okay. So let's continue. Actually, we are ahead of time. And so it means that you should really not hesitate asking questions, right? It's totally fine. We really have the time to answer questions. Actually, one of the reasons why we are also a bit ahead of time is that I restructured this syntax section of the course based on the feedback from previous semesters. So I used to go through all of the syntax, taking the time and so on. But it was a bit more boring than in other weeks where it's more intense and so basically what I thought is it's in the textbook anyway. Some of you already know the syntax XML JSON. So on your offline time, this is the 1A, the A part of the credits of the course. You are expected to self-study and make sure that you learn the JSON and the XML syntax, right? And so today tomorrow I'll go a bit quicker over them to make you aware of the most important aspects, right? So it's not that the XML syntax or JSON syntax is interesting, is that you cannot not know it. This is how I would put it. You really have to know these syntaxes, right? This is a must. Okay, but first I have to justify why XML and JSON. Why don't we use CSV basically? Because we could just put everything in table and then be using CSV. Well, it has to do a lot with how we use the system. You know, every system that we design, be it a relational database, be it a file system on your laptop, be it ChatGPT, anything, every system is built to work under specific ideal conditions for which it is optimized. And if you use the system outside of these conditions, then probably it will not behave as expected or be as fast. I can give you an example. You open ChatGPT and you drop into it the CERN data set with the petabytes of data, right? Probably that's not going to work because ChatGPT was not designed for this. It's designed for people to enter a bit of text, maybe upload some PDFs and so on, but it's not designed to drop petabytes of data at it, right? If you wanted to do this, you would create a different system. Or imagine that you take a relational database like PostgreSQL, and then you create tables in there that are very sparse. A lot of nulls everywhere because you don't use all the columns and so on, extremely sparse. You might notice that the performance might not be as expected based on what you might have expected. As another example, the typical relational databases systems historically, they were designed for a few hundred columns at most, right? 255, 256 columns. I think now you can do more, but historically there was this limit. Also, a relational database system like PostgreSQL is not meant to store trillions of records, right? Maybe you could push it in the billions if you push a bit, but millions or thousands is more the cruise mode of a system like that. And this is why newer systems were designed to handle trillions or quadrillions of records, including actually S3 and so on, where we can have billions or trillions of objects. So yes, what I'm saying is there is a domain of usability if you use the system for what it was for. And in the world of databases, there is one of the way to look at the world with just two classes is there are the database systems that read a lot, and there are the database systems that write a lot. And there is a name for these systems. Do you know the name for when we read a lot? I mentioned it earlier today. Yes? OLAP. And OLTP for the other one, exactly. OLAP is when you read a lot, online analytical processing. And OLTP is when you write a lot, online transaction processing. They sound a bit fancy, But in fact, if you want to picture OLTP, it's just the daily business of a company. It's Amazon selling books and taking orders. It's ETH, the ETH databases with the grades of the students and the credits acquired and so on. There's a database, and all the study administrations are just updating the database as you study, right? So these are the databases that are frequently updated. And on the other hand, we have OLAP, and OLAP is more like you download a data set and you query it, but you don't modify it. The data set from the CERN would be OLAP. You don't modify the data set, you just take it as it is, right? The ones you download from the internet. And whether you are in the one or the other situation makes a big difference on the way you're going to implement your system. So this is why on this slide, I show you the two directions. Of course, it's not exactly either here or here, right? It's kind of a whole spectrum. But basically, we have OLTP right here, where you have frequent updates, many people at the same time. I'm thinking also flights or train reservations and so on. And here we love to normalize the data, right? We love to have the data in normal forms because we want to avoid the update anomalies. When we insert, delete, and so on, a lot of bad things could happen if we're not in normal form. And on the other hand, we have the read-intensive queries, where we do the exact opposite. We love to denormalize the data and put everything in a single table, because here, what we are scared of are the joins. We don't want to join data because joining is actually expensive, right? And so you really need to keep that in mind through the entire course. This OLAP versus OLTP, this read-intensive versus write-intensive, right? So I will keep talking about this. In many aspects of the course will be read-intensive, but we'll also discuss a bit of, read-intensive, but we'll also discuss a bit of write-intensive, some aspects, because people try to bring it back to the data lake. Maybe one last thing I can say, historically, the data lakes have been designed to be read-intensive. Who heard of data lake? Right, it's a super fancy buzzword that you see everywhere. Historically, the data lake were just like you drop your data in there and then you don't touch it, you just query it. But now there's been an evolution where we try to write to the data lake, and there's been a lot of new systems that will maybe I have a bit of time at the end of the semester to also show that a bit to you, like the Delta Lake, Iceberg, Apache Hudi. So this is new, right? All right, but anyway, I want to focus here when I talked when I mentioned the normal forms. When I mentioned this on the normal forms. This is my favorite slide because this is what we do with the normal forms in the course. But there is a reason why we do this. And again, the reason is here. The reason is that we are very much read intensive. And so we want to denormalize the data and to avoid the join. And this is why we actually do this. To make sure, because I did it in the first week, but to be really sure that everybody understands that, what you see on the screen right here is several tables where every table does one thing, right? We have a table of products, a table of sales, a table of customers. This is normalized data when we do things in this way. That's the intuition. The data is normalized because we have all of these tables. And when we want to actually query these tables, we have to join them. So we have a laptop here for 2,000 francs that is somehow connected to this entry right here, which is a laptop purchased by John, 3 of them actually. And then we also have John connected here to Zurich. So you see, the join is basically the connection of these records together, all the yellow records. That is called the join. And so when your data is in normal form, you have to do a join. And because we hate joins, at least when we are read intensive and we don't like the performance of joins, what we do is that we take these 3 tables, we join them back into a single table, and we are going to work on that table. That is now the way we store it. But of course, it used to be in high normal form, Boyce code normal form in that case, and now it's no longer in Boyce code normal form, right? But it's totally okay because we are read intensive. So it's totally okay that we have some duplication. You see, like this is duplicated. We have functional dependencies, John and Zurich, Mary and New York. If we were write intensive, that could bring a lot of problems. What if you update one value, but you forget to update the other one? Read intensive, no problem at all. So we denormalize to the first normal form. For the formal aspect of it, every one of these rows in here is a record. A record is a map from attributes to values, from string to values. So the one marked in green here, you can see product is phone, price is 800, customer John, city Zurich, and quantity 1. That's the math, right? This is what the mathematicians would see. And this is what the computer scientists see and probably like it better. That is the same thing expressed in which syntax? JSON, right? I even put it in the title. So this is the JSON syntax. So what this is telling you is that this is an alternative to CSV, right? I could have the comma-separated value on one line of this, but I can also put it in JSON like that. But the difference is that now I do have my attributes stored together with my values. In CSV, I don't. I just put the attributes on the first line and that's it. Then I just have the values. But here I have the attributes together with the values explicitly. So this is for one record. And what we are going to do is that if we have plenty of records, we can store it like this as text, where I have on every line of my file, I have a JSON object that represents a record. And this is called the JSON lines standard, right? JSON lines, you have one JSON object per line. A reason we can do that is that the indentation doesn't matter. It's not like Python, right? So here the indentation doesn't matter. You can pretty print it in this way, or you can put it on a single line. It's all the same. It doesn't matter. It's the same JSON object. Who is with me? Right? Okay, so this is JSON lines. And now you see it's another way than CSV to store it, but you immediately see the small drawback that we have here is that we have every time the attribute repeated on every line. But again, because it's really intensive, we don't really care. We might actually appreciate this, and I will show you why. All right, but I don't want to stop here because, as I said, we are throwing everything away. So the relational integrity means we don't have any holes in the tables or extra attributes. Domain integrity means in the same column, you have only values of a single type. Atomic integrity means you don't have a table in a table in a table in a table. And we are also going to throw this away. Remember, the first normal form is when you have only atomic values and you break it by nesting tables in tables. And I'm showing you again my favorite slides because we are also doing this with the first normal form. And that means that we are going to do some things like this. Right? Now we have tables in tables in tables in tables. It's not even in the first normal form, right? And it turns out that something like this cannot be done with CSV. Do you agree with this? Right? You cannot do this with CSV because CSV, it's comma separated, right? It doesn't have structure. It just has comma separation. Of course, if you feel adventurous, you could still find a way to encode the table as a string and then put it in a CSV file, but you have to realize that this is creating more complexity. And then you have to create conventions, you have to parse it, and so on and so on. So it's not something straightforward. So basically, CSV does not support this natively, but JSON does. Right? And that's the motivation. With JSON, we can encode that without any problem. That is one row with a nested table. And you can see that with JSON, I can have here an array of objects, right? And these are my 3 objects here that represent the rows in here. Then I put them in an array, and the array itself is in the orders column, right? Who is with me? Right? For whom is that natural? Right? Okay. And let's do it for another one. So here again, we broke again here the relational integrity because we don't have a value here. And you see with JSON, that's no problem at all. Because the advantage of having the attributes explicitly in there is that when you omit one, you know which one it is. Well, you know the ones that you have, right? So you know customer Mary, and here you don't have any quantity, so there's a hole in there, right? So what that means is that when we throw away the normal forms, it means that we go away from this, where we have a flat and homogeneous model, and we go to a nested heterogeneous model, where we have extra values. Some of the rows might have extra attributes, missing values, invalid values, because you might have different types in the same column, and nested values, right? normal form, denormalized, right? Write intensive, we love this. Read intensive, we love this. So now to again put it on the same slide, you have on the left a homogeneous collection of flat item, that's relational data. And on the right, you have a heterogeneous collection of arborescent items. Arborescent is because I'm French and that's the Latin word for tree-like, right? It's arborescent. So a heterogeneous collection of arborescent items. We refer this as semi-structured data. It was also a buzzword back then. So XML and JSON are semi-structured data. It means you denormalize. Okay. And you can see here, by the way, I put both some sort of visual, but you can see that it's not as structured as on the left, and then the equivalent JSON syntax for these two records on the right. We still with me? All right. Semi-structured is kind of in the middle between structured data, that would be the tables and the cubes, and on the other hand, the unstructured data, that would be the text, images, videos, and so on. The ones that are now commonly, we had a conversation during the break, stored as vectors in vector databases, and then you can throw a generative AI at it, or you can do proximity search with this, right? And here, with XML and JSON, with denormalized data, we are in the middle between structured and unstructured. We are semi-structured. And typically, semi-structured is associated with trees, right? You could argue that graphs, that we'll see a bit later, you could also consider this semi-structured, but people associate semi-structured with trees, typically, okay? Both XML and JSON are standards. XML is the W3C standard. The W3C is the World Wide Web Consortium, right? That's the same that standardizes HTTP, HTML, and so on. ECMA, the JSON is now an ECMA standard. ECMA actually, who knows ECMAScript, right? That's in fact JavaScript. It's related to the ECMAScript standard. And so JSON used to be an RFC, a request for comments, but now it's also an ECMA standard, right? And it sounds like a small detail that XML is a standard or JSON is a standard, but in fact, it's huge. Because what that means is that, unlike CSV, when you want to open an XML file for your project, imagine you have a programming language, anything, could be Python, could be Java, could be R, could be C, and so on. You want to open an XML file. Do you implement it yourself? No, because it's almost guaranteed that there's going to be a library that does that for you, right? Because it is a standard, you have all these libraries out there that just need to be implemented once, everybody agrees on it, and then you can open them and you can write them and create files, knowing that other people will be able to open them too, right? So this is the benefit of a standard. So it's both true for XML and JSON. XML is very strict. We'll see for JSON, there's a few things that might a bit differ, but the fact that it's a standard is extremely important, right? It's a lot of cost savings. If you have, imagine you have a new project and you need to create some files and you need a format for that, then it's a good idea not to invent a new format, but to just use one that already exists, right? So XML, JSON, it's already there and there's already libraries, right? So this idea of only implementing it once and then everybody uses it, and the idea of being able to producing something everybody else can open is very important. Are there any questions so far? Yes? Maybe we can just, so that way the people on Zoom can hear you. Go ahead.
So when we denormalize data, if you look at the perspective from tables, and denormalizing them usually results in storing more data, right? So when you usually have a foreign key in one table and it references the primary key, you don't have to store the information from the other table each time in the original table. So is that like a problem for reading fast? Because you like this throughput, you always say like the throughput is a big problem, and then you have to transmit more information.
So you're absolutely correct that when you denormalize data, you create redundancy, right? This is what you mean, right? Redundancy. You basically are going to have the same strings stored multiple times. Like in the case I showed, the attributes are basically repeated all over the place. So you're absolutely correct that it takes more space. At least when you store it as JSON or XML, it's going to take more space. This is true. Does it bring problems? Well, it would be problems if you would be write intensive, because this is what we call update anomalies. The intuition is that if you store the data redundantly and you want to update the data that is stored redundantly, then you need to be very careful to update every single copy of the data in exactly the same way. If you don't do that, then you have inconsistencies. So this is why when it's write intensive, we don't do that, or we avoid doing that. And this is why we love normal forms. When it's read intensive, we don't have this problem with the update anomalies because there are no updates. So then it's totally fine to be redundant. So now at first sight, you might think, okay, yes, but if it's redundant, then I have more to read. And so it's going to take more time to actually read the data. But you need to see that in the big picture, because in the big picture, the joins are also expensive, right? So the fact that you have tables and you need to join, that is a computation. And after the join, you will get redundant data too, right? When you join the table, then there is redundancy in there. So essentially, denormalizing means that instead of computing the join, you pre-compute it and you store the intermediate states that has the redundancy, then you just read it directly instead of computing it, right? And so you do have this gain in performance because you didn't join. You don't need to join anymore, right? And so the redundancy is a small price to pay, but typically in read-intensive system, it's worth it. You agree to take on a little bit of performance hit reading more data because you don't have to join anymore, right? Now there is another aspect, and this is something that I'm going to speak about probably in 2 weeks, is the fact that syntax, or let's say a text file in JSON or in XML, is only one way of storing the data, right? Typically, you store that data to make it, people can download it over the internet, they can easily edit it in a text editor and so on. But in fact, there are other formats. One of them is Parquet. Who heard of Parquet? Right, so this is another format, more space efficient. You can also store denormalized data in there, but then it's going to be much quicker to read. So while the redundancy at first sight sounds like a problem, it's a problem that can be mitigated. First, because you can use more efficient formats. And second, because you can also optimize in such a way that you only read what you need from the disk. And that means that a lot of data can be skipped completely from reading. So there are ways to compensate for this redundancy. Right? Does it make sense?
Yeah.
Right? Since we are ahead of time, I really took the time to answer because that is important, and I'll come back to this in the rest of the course. Right? Any other questions? Right? Okay. Yes, there is. Yeah, go ahead.
In the table that you showed before, where you were talking about the JSON standard this one, you denoted the type of, well, the entries in the table. Is that a thing in JSON at all? Like, for example, like product below that's a string of characters, then you got a numeric type. That's not a thing in JSON, right?
We'll do that in 2 weeks.
Okay.
So the idea is that at the syntax level, you just store it's basically data that is in a raw format. And then when you are interested in the types, that's what we call validation. You validate the data. It means you have a schema. And that means that just like you have a schema, so basically the upper part of the table here is a schema, right? And the idea that has also to do with denormalization is that we throw away the schema and we just directly store the data itself, but without any schema. The idea is that we decoupled the schema from the data because you could keep a schema somewhere else. You could also completely throw it away, or you could have data that is in a mess, you clean it up, and then you bring a schema and so the benefit of XML and JSON is that you may or may not have a schema. You have that flexibility, right? And so we will see in a couple of weeks how you can say product is a string of at most 30 characters, price is a numeric, orders is an array of objects, and so on. We'll see how we can do that. You can absolutely do it. So that's also a good question, and also a preview of what we'll be doing in 2 weeks, right? Okay. And also a last thing that I want to say is that if you visit internet forums, you will see, so first, if you want to troll Reddit or an internet forum, ask, is JSON or XML better? Huge troll, that I guarantee you, and people have done that in the past. There's a lot of matter of taste in here. You can like XML, maybe you don't like XML, maybe you like JSON, maybe you don't like JSON. But again, what matters is that they are standards. It's not about liking them or not liking them. It's about the fact that this is a standard that many people agree on, and you have the parsers and the libraries that allow you to open them, right? And we'll see also the difference. So they are both trees, so in a way, it doesn't matter which one you use, but there are a few differences that we will see in terms of use cases. All right, any other questions before I continue? All right, then I'll continue. So first, a bit of theory. When we say syntax, we in fact talk about languages. And when I use the word language, I use it in the sense of theoretical computer science. Who has heard of a language in theoretical computer science? Yeah, many of you, right? So a language in theoretical computer science is basically a set of strings, right? And there are strings that belong to that set, and there are strings that do not belong to that set. So in essence, you take some text and you ask, is this or not well-formed XML? Is this or not well-formed JSON? It's a yes-no question. If the answer is no, well, too bad. If the answer is yes, then you can open it, parse it, you will have the syntax highlighting, and then you can start working with it. So the notion of a language is really a yes-no question. Is it or not part of this language? And then what you see in theoretical computer science is that there's a lot of theory about the description of these languages. There are languages that can be described with regular expressions. There are languages that can be described with context-free grammars and so on. Here we are a bit beyond that. This is more complex because there are a few constraints that cannot really be expressed as regular expressions or context-free grammar, right? But the spirit is the same. These are languages. Even though they are complex, there is this yes-no question. Is it or not well-formed XML? Is it or not well-formed JSON? Remember this word, well-formed, well-formed. It's very important because it's commonly confused with valid. We should not use the word valid. Do not say it's valid XML or it's valid JSON. That means something else. And that has to do with the data types that you mentioned a bit before. You really have to get into the habit of saying it is well-formed. It's well-formed XML, it's well-formed JSON. Valid only makes sense if you have a schema, and that we will see in 2 weeks. Okay? So this is a language, and now we have 2 of them. So XML is one language. This is what it looks like. I'm assuming many of you already saw that. Who saw that before? Okay, and this one, who saw that before? Even more, right? My next question to you is, who sees a tree here? Okay, who doesn't see a tree yet? I will make you see the tree. And who sees a tree here? Okay, who doesn't see the tree yet? Right, I will make you see the tree also. I'll have a week on the memory representation and so on. You will see that this is only syntax, it's only text, but then you parse it, and then in the memory you have a tree. And ideally, knowing XML and JSON means having the intuition of the tree representation of this. You should not just see text, you should really see a tree in your head. And this is why we are going through it to making sure that everybody knows them very well and has an intuition. So I start with JSON, but again, it's a shortened version compared to what was done before. So I changed the slides completely, right? So I quickly go over this, just show you what there is in JSON. In fact, there's only 6 things in JSON, as we will see, 6 syntactic building blocks. So I highlight them. Let's start with strings. So here I highlighted in blue and made bold all of the strings. You can recognize the double quoted strings like this. This is a string, this is a string, this is a string, this is a string. Everything that here is blue is a string, right? They're all over the place. So this is one of the 6 syntactic building blocks of JSON. And just for completeness, you can also escape characters. You know \n is for a new line, and you also have \u followed by 4 symbols. That's Unicode. Remember Unicode, where I told the catalog earlier? When you can use the Unicode code point, that would be in base 16, you can represent any character, including your favorite emojis, using the \u like this, right? So these are strings. Then we have numbers. So in that case, there's only one, but of course in dataset, you would have plenty of them. The first thing you notice is there's no quotes around that number. It's just a sequence of digits. But it can be more than that. It can be negative. It can have a sign. It can have a decimal period and digits. And it can also have an exponent of 10, right? You know the scientific notation, right? This means times 10 to the power of 63, right? Of course, there are not so many people in Switzerland, but this is my, and not a negative number, but this is just an example, right? So it's a generic syntax for numbers. Also, the JSON standard does not put any limits on the precision. You could have 1 billion digits if you want, with the dot anywhere you want. That's still well-formed JSON. It does not mean that all the libraries will be able to open it, right? Libraries can have library-specific limitations, and it's in their documentation, but by itself, JSON doesn't limit the precision. Is there a question on Zoom, I see?
On Zoom. In the slide about syntax heterogeneity, the nested table doesn't have quotes for John, Peter, etc. So is this not well-formed JSON?
Let me go back and let's see together. Here?
Yes.
Yeah, all right. So here, let me explain why there are quotes at the bottom and not in the table. When I say that the strings are double quoted, this is in the JSON syntax. It means that in the JSON syntax, you put the double quotes to say that you have a string. But the quotes are not part of the string. In the memory representation, this is really just a phone. This is this. Ah, now I see. Maybe you saw it different. Yes. No, now I see it. I was. Yes, you're right. That's a mistake. I will fix it. Yes.
Great,
this is indeed not well formed, and I will put the quotes around this. Yes, thank you. That was funny. All right. Very well observed, and it means that you're following what I say. Okay, so we have the strings, we have the numbers, arbitrary precision. Note that when I say number, at that point, I am not saying if that's a byte, an int, a long, a negative integer, a double, a float, a decimal. I'm not saying anything. It's just a number in that syntax. And then with validation, we will see if you want specific types in memory, how you can do that, right? But now it's just a number with what we call a literal of a number. A literal is a number. It's just the sequence of digits and points and signs and is that you have in there. Okay. Then we have Booleans. Booleans are also not quoted. It's also just a literal. Well, there's just true and false. And that's pretty much it. I don't think that I need to say anything else, right? You're computer scientists, you know Booleans. So true, false, and I also add null, right? Here, there's also a special value called null. It just, you could compare it with the SQL null when you have a table where you put a null and so on. But there is a small observation that I have to make here in terms of what it means when you read a file like this. When you have a null in a SQL, in a relational database, it basically means the value is not there, right? Because you cannot just remove the attribute in a relational table. The attributes are on every row. But in JSON, you can actually do two things. You can either say capital colon null, or you can completely remove it. But in JSON, that's different. To remove the key completely or to say it's equal to null. So you have a difference that you don't have in SQL. So it's a small subtlety. By the way, there is no capital city in Switzerland. It's not in the constitution or anything. It's a fun fact about Switzerland. We say it's Bern because it has the federal palace and so on. But there is actually no capital city in Switzerland, only de facto. All right. So that's four things, sorry, four. The strings, the numbers, the booleans, and null. And then we have two more that are the structured constructs, right? So the first four are atomic, strings, numbers, boolean, null, atomic. And now we have objects and arrays. So the arrays look like this, right? With the, you can recognize the square brackets, and it's just an ordered list. The order actually matters, an ordered list of values. In that case, it's all strings, so it's pretty structured here, but it doesn't have to be. I could also have an array with just a huge mess, right? So a number, a boolean, a string, even a nested object, a null, and so on. And that's totally fine in the JSON syntax, right? It's totally allowed. It's well formed. Some other comments. It's what I said earlier. The indentation is purely optional. It's for us human beings that it makes it nicer to indent things and so on, but it's optional, right? You can do this or this. It's exactly the same thing. That's called pretty printing. It can be useful actually to see more easily the JSON syntax. Okay, and now the objects, the last one. So the objects you can recognize with the curly braces, like this. The objects can also be nested. So here I changed, instead of a string, I put an object. So there you have an object in the object, right? And you can also have objects in arrays. So now I have all of the 7 counselors, federal counselors. So now you have a structured sequence of objects in an array, right? That's the sort of things that you want to design a schema for, right? Because whenever you see structure in the data, then you can say it's an array of objects where first is a string and last is a string, right? But that we'll see in 2 weeks, right? When we can enforce these kind of structures. A few don'ts. The keys here must be strings. You cannot have anything else. So an array, for example, that's not permitted. You cannot have unquoted keys, so like an integer or even an unquoted string, that's also not okay. And you cannot have twice the same key in the same object at the same level, right? So this is also not allowed. But I have 2 comments on that, on this and on this. So I'll start with this. The parsers for JSON have a bit of flexibility, and the technologies that use JSON have a bit of flexibility. Some of them might not reject the input if the key is unquoted. So that actually might successfully parse with some of the JSON libraries, and with some others, it might be rejected. That's because normally the standard says you need the quotes. So basically, when you implement a parser or a library, when you still accept small mistakes, you're basically being nice to the users, right? So you're saying, okay, that's fine. It's unquoted, but I can still parse it for you. The rule here basically is it's nice to, when you open or parse a file, to accept a few non-standard constructs. But when you create JSON, you should really, really stick to the strict standard, right? So if you create JSON, always quote your keys. Why? Because you're making sure everybody can open them with any library that you would use. So this is the idea. Again, you can be lenient when you read, but you should be strict when you write content. For whom does that make sense? Right? So that's the first thing. The second thing is that the repetition of keys, so duplicate keys, technically is not enforced by the standard. The JSON, the RFC standard of JSON says it should not, there should not be duplicate keys. Should. You know that in the standard, there's these verbs like should, must, may not, cannot, and so on. They're usually written in uppercase letters. And so that's a should. You should not do that. So what that means is that at some places it will be tolerated, and at some other places it will not be tolerated. But in the context of data, when you have data sets that you want to open in the document store or read with Spark and so on, you really should treat the should as a must. That's a must. Because the moment you have colliding keys like that, you're messing up your data model, right? Because there's the idea that you have attributes like the columns of the tables, and that's supposed to be non-ambiguous, right? So you know the saying, right? You treat all warnings as errors. So we treat the should as a must. And for the class here, we forbid that kind of things. In the ECMA script, somehow it disappeared, and it's not even a should. It doesn't even say anything about duplicate keys, right? But again, in practice, you would have a lot of database systems that do not accept duplicates. Okay, still have a few minutes to go. I want to show you, I'll just finish on JSON for today. This is a real-life data set. It's called the Great Language Game. Who actually heard of that language game? It actually stopped. So a few years ago, you could play online a language where it would play an audio file to you of people speaking in a language, and then it would give you 4 choices, like what language is that, right? Is it English, French, German, Arabic, Hindi, Chinese, Mandarin, Japanese? Like you need to decide which one of the 4 it is. And so what they did, because a lot of people were playing these games, is that they recorded the answers that people gave. And they stored it like this as a data set, where in that case, the audio was played that was Italian. That is an ID for the audio, an identifier. Could be an object ID for an S3 bucket, I don't know. Then in that case, it was displayed, is it Chinese, German, Italian, or English? The person said, I think it is German, but in fact it was Italian, so that was an incorrect answer, but they thought it was German. And that is the date at which this choice was made, and then the country in which it was made, right? So there is a data set like this that was collected. It has 16 million, it's not that big actually, 16 million objects, and we use it periodically in the exercises because it's a nice JSON data set. It's a good exercise to convert it to Parquet, by the way, when we see the validation. But yes, this is to show you JSON in real life as a data set. And again, I'm showing this again. You can store in a JSON lines file, you can store a table like that without the schema. Again, we'll see that the schema in 2 weeks, or nested data like this, or heterogeneous data when you have, so here it breaks both the relational integrity because you don't have any value here, not even a null, and it breaks domain integrity because you have a string and an integer, right? So here you don't have, you basically, I put whatever in there, right? Another word for whatever is variance, but I'll also discuss variance maybe a bit later. So I think I can let you go. Tomorrow we'll look at a bit at XML and namespaces. We might even stop before the end of the hour. And then next week we'll look at white column slots. So thank you very much, everybody. See you tomorrow.